Hello everyone, it's Mrs. McCready here, and I'm going to take you through C13, Chemistry of the Atmosphere for Combined Science. There are three topics that we're going to cover during this session. They are how has our atmosphere developed, greenhouse gases and how they are linked to climate change, and also pollutants in the atmosphere. So there's a do now for you up on the board, just some math skills questions, so your teacher can pause the video here and then come back to go through the answers. Okay, so the three answers are up on the screen here. These were fairly simple mathematical manipulations. Again, if you weren't quite confident on these, that's maybe something to look at before you do your assessments. So the first topic we're going to talk about today is how our atmosphere has developed from the Earth's early atmosphere. And when we talk about the Earth's early atmosphere, we mean what the Earth was like when it was first formed. And we're talking billions of years ago here. So when the Earth first formed, it was just a ball of molten rock, so just melted rock, and the surface was covered in volcanoes. There was no land as we would recognise it today. There were no oceans. The atmosphere around the Earth was mainly carbon dioxide and water vapour. So over time, the Earth cooled down. And when the Earth cooled below 100 degrees, water vapour could condense and form the oceans. Carbon dioxide that was in the atmosphere, a lot of it dissolved into those oceans when they formed. We also got some very simple organisms like algae evolving about 2.7 million years ago. And those algae took in carbon dioxide for photosynthesis and released oxygen in that process. Some carbon dioxide was locked away in sedimentary rocks and fossil fuels. What we mean by this is those simple organisms that were taking in carbon dioxide for photosynthesis converted that carbon dioxide into glucose during that process. That glucose became part of the plant, and when those plants were perhaps eaten by animals or other living things, that was locked away into their shells and skeletons. When the plants or the animals died, they were compressed and formed fossil fuels. So some of the carbon dioxide that was taken in by those plants originally got locked away in the formation of sedimentary rocks from shells and skeletons, and also into fossil fuels. Methane and ammonia that were present in the Earth's early atmosphere reacted with oxygen as it began to form to produce nitrogen gas, and the nitrogen builds up over time because it's very unreactive. So I'm going to show you two pie charts here. The top one here is the Earth's early atmosphere. You can see 95% was carbon dioxide, 4% water vapour, and then trace amounts of nitrogen, ammonia and methane. The surface temperature was above 400 degrees, so that's why we couldn't have those liquid oceans as we recognise today. Now, through the processes that I've bullet pointed here, the Earth's atmosphere today is very, very different. There's far less carbon dioxide. We only have trace amounts of carbon dioxide in our atmosphere today. We also have less water vapour. Remember, that's condensed to form the ocean, so there's less of it in the atmosphere around us. We've got an increase in oxygen. That happened because of the plants evolving and completing photosynthesis and releasing oxygen during that process. And finally, we talked about the increase in nitrogen at the bottom there. And because nitrogen is unreactive, it remains in the atmosphere and doesn't get cycled like other gases. So 78% of our atmosphere today is nitrogen, 21% is oxygen. You will need to learn those two numbers for your assessments. So the next thing we're going to cover today is greenhouse gases, what they are, how they affect the Earth's atmosphere, and also how they affect climate change. This diagram shows us what we mean by the greenhouse effect. Now, the greenhouse effect is a perfectly natural effect, and if it wasn't happening, then there wouldn't be enough warmth on Earth for us to survive. So the greenhouse effect is important, but we'll talk about why it might be a problem in a minute. So you can see here, the sun gives off ultraviolet rays, UV radiation, and that comes to the Earth. When that UV radiation hits the Earth, some of it is reflected and bounces back off through the atmosphere. You can see that on the yellow arrows here. And the rest of it is absorbed by the Earth. When the Earth absorbs that radiation, it warms up. So the Earth cools itself again. It gives off infrared radiation to cool itself. And because that infrared radiation has a longer wavelength than UV, cannot all pass back through the atmosphere and it gets trapped. You can see that demonstrated by the orange arrows on the right hand side of the diagram, and that radiation gets trapped and warms the atmosphere. So greenhouse gases, carbon dioxide, methane, water vapour, they're all essential for maintaining the Earth's temperature at a level that can sustain life. And over the last century, the level of those greenhouse gases in the atmosphere has increased, which enhances the greenhouse effect I just talked through in the diagram. So those greenhouse gases are absorbing the infrared radiation in the atmosphere and causing it to increase its temperature. Some human activities have increased the level of these greenhouse gases. So carbon dioxide is generated from burning fossil fuels for things like transport and factories. Methane is also released from cattle farming, rice fields, and an increased use of landfill sites. Deforestation to provide wood for building materials also decreases the removal of the carbon dioxide from the atmosphere that would naturally be happening when the trees are there. So if we cut down those trees, we're decreasing the removal of the carbon dioxide from the atmosphere, alongside, in that third bullet point, generating more carbon dioxide from human activity. So why is this increased greenhouse gas level a problem? Well, the increased greenhouse effect causes global warming. It causes the increase in temperature of the Earth. And that global warming leads to climate change. So the increased greenhouse gas levels, so for example carbon dioxide and methane, leads to global warming. And that global warming leads to climate change. And by climate change, we mean changes in weather patterns and changes in rainfall. So we get increased extreme weather. You will have seen lots of stories recently in the news about forest fires, and there have recently been stories as well about flash floods, drought, so all of these increased extreme weather events that wouldn't have happened beforehand. We also get increased drought where there isn't any rainfall. Now this has a really knock-on effect in terms of food shortages. A lot of our food requires water from rain to grow. If that rain isn't falling, the food won't grow and there will be a shortage of food. Increased temperature leads to melting of the ice caps. That leads to rising sea levels, which can cause flooding around lower lying areas. Also, all of those changes can lead to habitat destruction, which could ultimately lead to extinction of species. So there's a lot of effects here that can be caused by climate change, which has happened because of those increased greenhouse gas levels. The final topic we're going to talk about today is pollutants in the atmosphere. So we're going to talk about how us burning fuels leads to an increased level of pollution in the atmosphere. We've already talked a little bit about carbon dioxide. Carbon dioxide is formed as a product of combustion of fuels, and we've talked about the fact that that is a greenhouse gas and can lead to global warming. But there are 4 other pollutants that you need to know. You need to know how they're formed, and you need to know the effect that they have. So our first is sulfur dioxide. Now, a lot of fossil fuels contain sulfur impurities in them, and when you burn those fuels, the sulfur combines with oxygen to form sulfur dioxide. Sulfur dioxide causes acid rain, and the problem with acid rain is that it corrodes anything made of limestone or a similar material. So you can see in this picture here, this is the erosion of a statue over a period of time. On the left, we have the original statue, lots of detail in the clothing and in the face, and on the right hand side, after the acid rain has eroded it away. The second pollutant is carbon monoxide. This is produced if you burn a fossil fuel without enough oxygen. So we call this incomplete combustion. So incomplete combustion happens when there is limited oxygen. And carbon monoxide is a toxic gas. It's poisonous to humans. Be careful here. Don't use generic words like harmful or dangerous. You must be specific. It is toxic or it is poisonous. The problem with this gas is that it is odourless and colourless, so it's very difficult to know when it's being produced. If you have a gas boiler in your house, you will also have a carbon monoxide alarm that will tell you if this is being produced in your house. The third pollutant is nitrogen oxides. This is a generic term for any compound that contains nitrogen and oxygen. This actually isn't coming from the fuel itself, but it's coming from where high temperatures inside the vehicle engine causes nitrogen and oxygen that are in the air around the engine to react with each other. And that forms these nitrogen oxides. The problem with these is that they can trigger asthma and other breathing problems, and they can also contribute to acid rain. Our fourth and final pollutant is particulates, and we would sometimes call that just soot. So these are very small solid particles of carbon that are produced again when fossil fuels are burned without enough oxygen. So it's the carbon that's in the fossil fuel that isn't being oxidized and therefore just remains as solid carbon particles. One of the problems with this pollutant is that it causes global dimming. You can see this picture of a city here. You might have heard the term smog, and that is a fog that contains soot and smoke, and it reduces the amount of light getting to the ground level. Okay, so we're just going to tackle some quick questions now. There are 7 questions that are going to come up on the screen, so your teacher will pause the video here and then come back when you're ready to go through the answers. Okay, so if we go through the answers here, the main gases in the Earth's early atmosphere were water vapour and carbon dioxide. There were no oceans in the Earth's early atmosphere because the temperature was above 100 degrees or the temperature was too hot. The main gas in the atmosphere today, making up 78% of our atmosphere, is nitrogen. Ways in which carbon dioxide has decreased: it could have dissolved in oceans, could have been taken in by plants for photosynthesis, or locked away in sedimentary rocks and fossil fuels. Human activities that have led to an increase in greenhouse gases: we've got burning fossil fuels, deforestation, increased use of landfill, or increased cattle or rice farming. The way in which nitrogen oxides are formed is the high temperatures in car engines causing the nitrogen and the oxygen in the air to react with each other. And the reason that you wouldn't want to burn a fuel with a high percentage of sulfur is that you'll form sulfur dioxide, which contributes to acid rain. So we're now going to try 3 exam-style questions. The first is up on the screen here, worth 3 marks. So your teacher will pause the video here, give you a chance to read through the question and write your answer, and then come back when you're ready to go through it. So the answer to this question is that incomplete combustion happens because of limited oxygen, and then your final mark is for saying that carbon monoxide is toxic or poisonous. Remember, you need to be specific with your language there. Harmful or dangerous will not get you the mark. You must write toxic or poisonous. Here's the second of our 3 exam-style questions. This one's a little bit longer, so your teacher will pause the video again here and come back when you're ready to go through the answer. So nitrogen's making up 78% of the Earth's atmosphere today. And then the second part had asked you to explain the changes to oxygen and carbon dioxide levels from the Earth's early atmosphere. We can see from the table that carbon dioxide has decreased and that oxygen has increased. So we need to give reasons, explain those changes. So we know that the Earth cooled enough for water vapour to condense and to form oceans, and then the carbon dioxide could dissolve in those oceans. We also know that carbon dioxide was taken in by plants for photosynthesis, and that during that process, oxygen was released. Our final point is that carbon dioxide was locked up in sedimentary rocks and fossil fuels when they were formed. So here's the final of our 3 exam-style questions. This one's worth 6 marks. Have a think in this question about how these 2 concepts link together. So the idea of carbon dioxide emissions and the consequences of those. So have a think about what the consequences would be. Make sure you include some of those in your answer, but also make sure you include some basic detail about why carbon dioxide emissions are a problem. Your teacher will pause the video once more here and come back when you're ready to go through the answer. So the problem with carbon dioxide is that it is a greenhouse gas, and we know that an increase in greenhouse gases would cause increased global warming, and that global warming leads to climate change. So we're linking that concept of carbon dioxide right through to climate change. Then we're going to give some consequences of climate change itself. So things like melting of ice caps causing sea levels to rise, that causes flooding, habitat destruction, which could potentially lead to extinction of species, and also increased extreme weather events, which could lead to food shortages or drought. Okay, so we've come to the end of today's session on C13, Chemistry of the Atmosphere for Combined Science. We've covered 3 topics today. We've covered how our atmosphere has developed over time from the Earth's early atmosphere to the one we have around us today. We've covered greenhouse gases and the effect they have on climate change, and we've also covered pollutants in the atmosphere, how they're produced, and the problems that they cause. If you've still got a little bit of time left during this lesson, you'll probably want to revise these concepts a little bit more. You could, for example, create a mind map, or you could create some revision questions and swap with a partner next to you and complete those. Really well done.